All right, so picking up on this second part of this video, we left off at question 8. So we're looking at question 9, which is another power over a quotient rule. Okay, so we're going to take this power of 3. So we have 3 to the imaginary 1 times 3 because of our power rule. And it's x to the power of 3 times the power of 3 that is being risen to. And that's all over 2 to the first times 3. Okay, so now I've implemented my power over a quotient rule. So now I just need to simplify this. So 3 to the third, x to the ninth, 2 to the third, which will give me 27 x to the ninth over 8. All right, so question 10. This is another one that is similar to the one we did at question 7 with those m's, right? Because there's a few different ways we can do this. Okay, so um, first off, I see like there's x's, y's, and w's, so I can't apply my quotient rule, right? However, my negative exponent rule, it just says that if I have a base raised to a negative exponent, I just reciprocate that, and then my exponent will become positive, right? So if I have an expression raised to a negative exponent, I can just reciprocate the expression and make the exponent positive, right? So what I mean is that I can just flip this exponent or this expression. So this just becomes 3y to the fifth w over 4x to the seventh. And now this is all raised to the positive 2, right? So I just did my negative exponent rule, right? I could have also did my raising a power over a quotient rule, and I could have just put this negative 2 into everything and then reciprocated it later, right? It doesn't matter which way you go as far as which one of those you do first. All right. So at any rate, I'm now going to apply my my power rule, right? And I'm gonna put this 2 into all 5 of these uh, different values, right? So this is going to become 3 raised to the imaginary power of 1. So 3, the imaginary power of 1 times 2, y to the fifth times 2, w, imaginary power 1 times 2, all over 4, imaginary power 1 times 2, x to the seventh times 2, right? So I implemented my power over a quotient rule. So now I just need to simplify 3 to the second, y to the 10th, w to the second, over 4 to the second, x to the 14th. And now just simplify these real numbers to their powers. So 3 to the second is going to give me 9, y to the 10th, w to the second, over 16x to the 14th. All right. So question 11. Um, Again, we have a few things going on, right? So we have what appears to be our product rule as well as our power over a product rule. So before we can combine our x's, this is one of those ones where PEMDAS becomes important, because in PEMDAS, before you do multiplication, you do your exponents. So same thing here. You want to do that first because it just makes it a little easier when you're when you're simplifying this at the end, right? So we're going to say 5x to the 6 y, and then we're going to implement our power rule with the 3, okay, because that's going to be times 3 to the second, x to the 6th, y to the 10th, right? So I did my power rule, okay, and now I can do some combining of like terms. So 5 times 9, because that's 3 to the second, 3 times 3 is going to give me 9, and then times x to the 6 plus 6, times y to the 1 times 10. I'm sorry, plus 10. Plus 10, not times 10. Right? So we get a grand total or finished product of 45 x to the 12th, y to the 11th. And we will be done with that one. All right, so now let's talk a little bit about scientific notation. Okay, so scientific notation is in the form of m times 10 to the k, okay, where k is an integer, meaning it can be positive or negative. Okay, and m must be bigger than or equal to 1, but less than 10. All right, and sometimes this might be described with using different variables. That doesn't matter, right? It's just making sure you understand it. Now, here's one thing you need to make sure you know is that when you look at this integer, if it's negative, it's saying that this final solution, because they want us to go to standard decimal form, it's going to be smaller than 1. All right, so if you just think about your negative exponent rule, this basically is saying 1.245 times 1 over 10 to the 5th, right? And if you take 10 and to the 5th and convert that, that's just 100,000, right? So you're going to just divide 1.245 by 100,000. Or you can simply just say, okay, 1.245. This is what is awesome about a base 10 system, meaning I have a base of 10. Negative just means I'm doing division like we just proved by working our negative exponent rule, right? So all I'm going to do is I'm just going to take my decimal and I'm going to move it 5 places left. So 1, 2, 3, 4, 5. And then I'm going to put my zeros in there for my placeholders, replace my decimal. Excuse me. And so our final solution is going to be 0.00001245. Okay, and we're done. You don't have to do a whole bunch of calculations with your calculator. I mean, if you want to check it, you can go to your calculator. You can say 1.245 times 10 raised. Make sure you use your negative button below your 3, not your subtraction button, or you're getting error. And this might be so small, it might keep it in scientific notation, which it did, right? So it's saying anytime you see this E, right, that just means, hey, this is so small, I'm putting it in scientific notation. Because it's -5, it means take your decimal 5 places to the left. If it was +5, you guessed it, take your decimal 5 places to the right. Okay? All right. So let's take a look at question number 13. Okay, 4.57 times 10 to the 6. Okay, and so this is positive. Therefore, we are going to move our decimal 6 places to the right. Okay, so 4.57. Then we're going to move that 6 places to the right. So 1, 2, 3, 4, 5, 6. Put in my zeros, right? And so we get a final solution of 4,570,000 as our solution. All right. So when we start to convert to scientific notation, okay, a couple of things you got to be aware of, okay? If the number is bigger than 1, that your integer, that k value, it is going to be positive. Okay, if my number is smaller than 1, then that k value is going to be negative. All right, so remember our m, you know, the number, the number that we're putting into scientific notation, it has to be 1 or bigger, but less than 10. Right, so for this number, in order for that to take place, we got to put a decimal right around here. Right, so if I just count my decimal places going backwards, 1, 2, 3, 4, 5, 6, 7, I know that this is going to be 3.65 times 10 to the 7th. All right, so again, if my number is bigger than 1, this should always be positive, my power. Okay, well, my number is smaller than 1. This power is going to be negative, right? So again, 1 or bigger, but less than 10 would be 6.3. So I got 6.3 times 10 to the negative. Well, I just got to move my decimal. 1, 2, 3, 4, 5, 6, right? And that would be my solution. Okay, again, you can check, especially the bigger one, 3.65 times 10 to the 7th. And this one, it should convert. Yeah. So you see you get 36,500,000. This one's going to be too small. So if I go 6.3 times 10 raised to the negative 6, it's just going to put it back in scientific notation because it's so small. All right. So when we're looking at division, so just like our quotient rule, right? It's very similar. Okay, so first we need to take those values and divide them. We need to say, okay, what is 8.36 divided by 1.1? And we get 7.6, 7.6, right? And now we just work our quotient rule, times 10 to the 29th minus 9, which gives us 7.6 times 10 times 10 to the 20th. Okay, and again, if I wanted to check that, it's going to put it in scientific notation, but I would say 8.36 times 10 to the 29th, close my parentheses, divide that by 1.1 times 10 to the 9th, and I get a solution of 7.6 times 10 to the 20th, right, which is what we found. Okay, multiplication just means we need to work our product rule, right? So 5.7 times 1.3, that's going to give us 7.41, which meets our rule that m is bigger than 1 and less than 10. 7.41 times 10. Now I just add these by doing my product rule. 6 plus 22 is going to give me 28. Okay, so notice I'm writing these a little different. Sometimes you'll get the X, which signifies multiplication. Sometimes you'll just get them butted up, which just means multiplication, right? Do what's inside the parentheses and then multiply to the other one. All right, but we're just kind of combining to save ourselves some steps. All right, so we got 8.5 times 10 to the negative 15th times 1.21 times 10 to the negative 4. So if I do my 8.5 times 1.21, I'm going, so I got a number bigger than 10, right? So this is 10, this is 10.285, which I got to do some converting of its own, right? Because I got to move this one place to the left. So that should be 1.0285 times 10 to the first, right? To get it back to this. And now I can say times 10, combine my exponents, even though they're negative. Negative 15 plus negative 4 is just negative 19. And now I can just work my product rule, 1.0285 times 10 to the negative 18th. Okay, and again, we can use our calculator to check this. 8.5 times 10 raised to the negative 15. Remember, use your negative button, not your subtraction button. And that's going to be times 1.21 times 10 raised to the negative 4. Equals, right? 1.0285 times 10 to the negative 18. All right. So again, hopefully these have been helpful as you continue to move through these concepts. But like everything else, if you find yourself getting stuck, do not hesitate to reach out. Talk to you shortly.